Hi, I'm Prashant. I will be presenting our ICLR 2023 paper, Task-Aware Information Routing from Common Representation Space in Lifelong Learning. Continued learning is a training paradigm in which data becomes progressively available over time. Some of the scenarios in continued learning include class incremental learning and task incremental learning. In both cases, continued learning model encounters data corresponding to new set of classes in every task. The task identity is available during training in both cases, while it's available during inference only in task incremental learning setting. Continued learning is quite challenging for deep neural networks as learning a new task causes catastrophic forgetting of older tasks. On the other hand, humans excel at continued learning. Acquiring new information rarely interferes with the consolidated knowledge. Continued learning in the brain is governed by a rich set of neurophysiological processes that harbor different types of knowledge, and conscious processing integrates them coherently. In addition, self-regulated neurogenesis in the brain increases the knowledge bases in which information related to a task is stored without catastrophic forgetting. Global workspace theory provides a formal account of cognitive information access in the brain and posits that one such knowledge base is a common representation space of fixed capacity from which the information is selected, maintained, and shared with the rest of the brain. During information access, the attention mechanism creates a communication bottleneck between the representation space and the global workspace, and only the relevant information is admitted into the global workspace. Such a system enables efficient continued learning in humans with systematic generalization across tasks. Inspired by the global workspace theory of cognitive information access in the brain, we propose task-specific attention modules in lifelong learning, a novel continued learning approach that encompasses both experience rehearsal and self-regulated scalable neurogenesis to further mitigate catastrophic forgetting in continued learning. Each task entails a task-specific attention module to capture task-relevant information in continued learning, similar to self-regulated neurogenesis in the brain. During training, we make use of task identity to select appropriate TAM for the current task samples. We use a matching criterion as an ignition event to select the appropriate TAM for buffer samples and during inference. Additionally, we also make use of an exponential moving average of the weights to consolidate previous task information better. Reminiscent of the conscious information access proposed in GWT, each TAM acts as a bottleneck when transmitting information from the common representation space to the global workspace, thus reducing the task interference. Unlike self-attention in vision transformers, we propose using a simple undercomplete autoencoder as a TAM, thereby rendering Tamil scalable even under longer task sequences. Here we provide an evaluation of different rehearsal-based approaches under class incremental and task incremental learning settings. Across all datasets, Tamil outperforms all of the rehearsal-based baselines considered in this work. As is the case in global workspace theory, TAMs capture task-specific features and reduce interference, thereby enabling efficient continued learning with systematic generalization across tasks. The performance improvement in class incremental learning is even more pronounced when we know the true identity of the task. Notwithstanding their size, this is a testament to the ability of TAMs to capture only the relevant information from the common representation space to the global workspace when warranted by a task-specific input. Analogous to our method, we attempt to augment several existing rehearsal-based methods by equipping them with TAMs. The above figure provides comparison of continued learning models with and without TAM when trained on sequential cipher 100. Quite evidently, TAMs drastically improve the performance of all continued learning methods, more so when the true TAM is used for inference. Inspired by the global workspace theory of conscious information access in the brain, we propose Tamil, a novel continued learning approach that encompasses both experience rehearsal and self-regulated scalable neurogenesis to further mitigate catastrophic forgetting in continued learning. We hope that this work engenders further research in developing brain-inspired approaches for effective continued learning. Please reach out to us for any further questions or discussions. Thank you.